Welcome everyone. Today we will discuss about an art of possible application followed by demo on large-scale document analyzer application, a solution that will provide a creative way on how we can handle and analyze large documents using generative AI and large language models. This application tackles a major challenge today, which is limited input context of large language models. These models are powerful, but they can only process a certain amount of text at once. I've solved this problem in a very innovative way by using a cumulative MapReduce approach, which allow us to process extensive documents from start to finish. I've implemented the flexible document segmentation, which lets the user specify different parameters like different page ranges for target analysis. We will see more in the architecture diagram on some other ideas on document segmentation. So why does this is important? Because this means that we can handle documents of any size, opening up the possibilities for document analysis and different use cases on top of that. So this application offers several key features. The first one is basically a very comprehensive summarization. We can generate complete summaries of the entire documents, no matter what their length is. And then the full entity extraction, which where we identify and extract all key entities throughout the document. We can do an extensive question and answer preparation where the system can prepare answers to a wide range of potential questions about the content. And then you can do a batch processing, which can handle large volumes of documents in a more scheduled batches. And then you can do an interactive processing where user can select specific documents, select their ranges, do an immediate analysis, allow for a very real-time insights. And these features are possible because we've overcome the input context limitation of the traditional LLMs through this creative solution. So what are the benefits? The benefits are that it will provide you a thorough analysis by processing the entire document for complete insight. It will become very cost effective at scale because it will reduce long-term costs through comprehensive pre-processing and efficient storage. And the solution is highly scalable. It can handle large volumes of documents and thereby overcoming input context limitation. Very importantly, it is secure and compliant. You can integrate your security measures to ensure data protection and policy compliance even in large scale operations. Let's look at some of the key technology aspect for it. First, we are going to use generative AI and LLMs as a foundation. The cumulative MapReduce approach allow us to process extensive documents end to end, and we will be using even prompt engineering into this as well. Flexible document segmentation, which lets the user target specific parts of the large document, and then you can integrate this with your knowledge bases where you can enhance retrieval speed and reducing cost. And our security guardrails will ensure that the AI driven insights comply with the data handling policies. So with that, let's go ahead and take a look at the demo. Welcome to the demo for large document summarization, where we are going to see a cumulative MapReduce approach. So in this UI, what I've done is that I've created few UI elements for us to see the demo. So here you will select the file that you would like to upload. You will select the large language model to process it. You can select the batch size based on your choice. So in this case, the document segmentation that I'm using is for the page, page by page. You can even do like semantic or any other approach that are based on your requirement. For this demo, I'm going to use the pages per batch. And then you can select your custom prompt. You can type your prompt over here, or you can look into the catalog that I've created for different industries. So it could be generic, legal, medical, or finance, technology for now. You can always extend this. So in this case, for the legal, I can select any of these use cases within the legal, or I can select under finance any of these. And once you click any of these options, then it will populate the prompt over here. You can even go ahead and update the prompt if you don't like it, or you would like to, add any more details to that. Another place is that you will, once the processing is done, then it is available to you on the PDF summaries page, which I'm storing into the Amazon DynamoDB. So let's go ahead and take a look at the demo. So in this case, I will select a PDF file, which is AWS overview about 160 to 170 pages. I will select the large language model. In this case, I'm going to use the Claude 3 Haiku, and then I'm going to use the batch size. So let's start with 10, a pretty big number. All right. And then go ahead and select the prompt. So I can select a generic prompt and say, I would like to get a general summary. So once you press the process PDF button, so what will it will do? It will take 10 pages content at a time. Um, Pass it on to the large language model and the prompt. So the content of those 10 pages are basically acting as a context along with the prompt, and then the output that I'm going to get will be used as an input for the next sequence of that batch. And then I've done a little bit of more prompt engineering to make sure that it remembers the context and it has some form of continuation there. So let's take a look at once we click on process PDF. So it's going to detect that there were 163 pages out here. It will take up the 10 pages content and then we'll pass it on. So as you can see, the first 10 page summary came in. I'm also calculating how much the input and the output tokens were for my tracking purposes. As you can see, it is going in a cumulative fashion. So as you can see, it went to page 1 to 10, then it went to 11 to 20. Now it is going 21 to 30. So it's going to go on with all of these different pages. So let's wait for this to quickly finish, and then we'll come back once it is over. So as you can see over here, it has processed all of the pages in the document. So as you can see in the history, it has processed all of the documents from like up to the page number 163. I'm also capturing the history for each of those cumulative output that is coming in. And this is the final output, which is basically it will tell you that, this is the final summary, how many total input tokens were there, how many total output tokens were there so that you can, do your tracking, and then the final summary. What you can do is that you can even store this final summary into your databases or into your knowledge base where you can then start querying the information so that now you have a summarized or a pre-processed document that is there. Another feature that I added is that you can click on the view summaries and then you can take a look at the history of what has happened. Is that in this case, I'm storing the PDF name, the prompt that was used, the summary, and so on. So you can even look at the information like what was the prompt that was used, what was the batch size, what was the model that was used, and then the summary of this document for your historical purpose. You can even delete or download the document if you would like to, but this is more for storing the history where you can now process this summary that was created based on the different prompts that you can store it, into your knowledge bases, or you can even cache the prompt information in case if somebody is asking a similar question, thereby saving a lot of processing and the cost over here. So yeah, so that's a quick demo that I wanted to show you on how to process large documents. And this is an art of possible by doing a cumulative MapReduce type of an approach. So yeah, and we'll take a look at the architecture as well. But thank you so much for watching the demo and happy building. Let's take a look at the architecture diagram of how did we implement the offline process or the cumulative MapReduce process for a large document. So we have used AWS as a preferred platform to implement this and predominantly using the large language models provided by Amazon Bedrock. So let's start with where user is going to go ahead and upload the large document. So the large document gets uploaded and then the information and then the document gets stored into the Amazon S3 bucket. So from here, the top part is basically all of the batch processing that would happen. And the bottom is basically how you're going to access the information once that batch processing is done. So you upload the document, it goes into the Amazon S3 bucket. From there, an event can be triggered. That event will take that document, and then based on the business rule that you have defined on how does the document segmentation would look like. So in this case, you can based on your rules, you can say whether it is chunk based or page based or and so on. And once that is determined, then that information is going to go passed on, and then you can apply your LLM processing on top of it, whether you want to do a summarization or entity extraction and so on. And then finally, you can do a document finalization step where you can either aggregate the results, do any other post processing or any final analysis that you would like to do. The output from there can either be stored into a database, as we saw in our case, it was Amazon DynamoDB, or you can even store to an Amazon S3 bucket where it would be used as a data source to be used by the knowledge bases for Bedrock, where you can vectorize that information and do semantic search or RAG on top of that. So from here, what happens is that the user is going to access the information through an API gateway. The API gateway is backed up by AWS Lambda function. That Lambda function can either query the information from the database that we saw into our summaries page, or you can even go ahead and ask us a relevant question based on your information that was pre-processed from there. And the Lambda function is going to talk to the knowledge bases for Bedrock, which apparently has the data source as the final S3 bucket over here. Alternatively, or additionally, I would say what you can also do is that you can also do the store the original information and its embedding for the semantic search as it is. So you now you have two documents. One is basically your original document, and the other one basically your post processing document, if you will, right? So now what will happen is that in this case, once you store it into the original S3 bucket and event can be triggered, the AWS Lambda can go ahead and store the information, help to store the information into the knowledge bases for Bedrock using the appropriate APIs. So that's a quick overview of the architecture for the MapReduce or cumulative way of processing your large document. Thank you for watching.